Damaging straight-line winds and large hail are expected, with the possibility of a few tornadoes, especially on Friday as the system intensifies. As colder air wraps around the backside of this deepening low-pressure system, rain will transition to snow across a vast swath of the country. Accumulating snowfall is likely from parts of Texas through the Midwest and into Michigan, with widespread totals of 4 to 8 inches and localized higher amounts possible. All right, everyone, we need to talk, and we need to talk now. The latest weather model runs just dropped, and they've introduced a development that fundamentally reshapes everything we thought we understood about the next 2 weeks. This is no longer speculation. What today's data is showing is a decisive pattern reversal, one that could finally unlock the major snowstorms we've been tracking for weeks. After days of advertising a cold but largely dry setup, the models have abruptly pivoted toward a far more dynamic and snow-friendly scenario, especially for snow lovers across the eastern United States. Before we break this down, drop your exact location in the comments. This new shift could impact areas that have barely seen a meaningful snowflake all winter. What I'm about to explain sheds light on why Arctic air arriving after this weekend may finally link up with storm systems, the very connection many of you have been waiting for. Until now, the biggest uncertainty has been whether this cold air would simply settle in quietly or actually phase with active systems to produce snow. Today's model runs take a major step toward a much snowier outcome compared to yesterday's guidance, which showed little to no storm interaction at all. We're going to break down exactly what this means for your region, including the timing of the Arctic intrusion and the snowfall threats worth watching closely. Starting with the European model, today's weather looks absolutely gorgeous, the kind that practically demands you step outside and enjoy it. Let me know in the comments what temperature you're seeing right now and whether you're appreciating this calm before the potential stormy shift. Widespread mid-60s across much of the region feels incredible, and we're even eyeing pockets of low 70s warmth later this week. As we head into Wednesday, the pattern remains relatively quiet and dry. Mild conditions holding firm across much of the central and eastern U.S. Most of the active weather is confined to the northwest, where snow continues, and the southwest, where a storm system delivers primarily rain. Meanwhile, the northeast sees a weak offshore low near New England, producing some light snow or mixed precipitation for parts of southern New England. But here's where everything starts to change. Thursday, the 8th introduces a pivotal development that begins reshaping the entire atmospheric setup. A powerful low-pressure system forms over the central United States, a large-scale feature capable of influencing weather nationwide. In its wake, colder air surges southward, bringing significant snowfall to mountainous regions out west, while Arctic air begins its descent toward the lower latitudes. Ahead of this system, a warm front surges north, creating a moist, unstable environment beneath and in front of the low. This contrast is critical, as it lays the groundwork for more complex winter weather possibilities as the pattern continues to evolve. By Friday, the transition intensifies. The warm front pulls additional moisture northward, fueling a more active setup. By Friday evening, thunderstorm development becomes likely across portions of the southeast as the system ramps up. Areas such as Alabama, Georgia, South Carolina, Tennessee, Kentucky, Virginia, and West Virginia all come into play. The highest thunderstorm potential appears focused on Alabama, Georgia, and South Carolina, though details will continue to sharpen as we get closer. Let me know in the comments which of these states you're in and whether you mentally prepare differently for January thunderstorms compared to their summer counterparts. Saturday night into Sunday marks another critical turning point as the cold front sweeps through and the broader pattern begins its transformation. Some of you may hear rumbles of thunder or experience heavier rainfall overnight. By Sunday 11th, the atmosphere reorganizes into a classic setup. Warmer conditions out west, colder air becoming firmly established in the east. A strong low-pressure system over northern Canada enhances snow shower activity and lake-effect snow across the Great Lakes. Monday the 12th reinforces this west warm, east cold alignment-tan arrangement that often precedes intriguing winter weather scenarios. By Wednesday the 14th, another upper-level low drops into the Michigan region. generating widespread snow showers near the Great Lakes. And this is where things get especially compelling. We begin to see a vertical jet stream configuration that favors coastal storm development. This jet stream orientation takes a more direct path up the east coast, a setup historically linked to significant winter storms, while early low-pressure signals appear offshore. They aren't yet fully organized enough to deliver major impacts. However, if a system of this type were to consolidate more efficiently, it could produce meaningful snowfall for parts of the eastern U.S. The models hint at better organization potential around the 15th into the 16th, placing us roughly 10 days out. At that range, the focus shifts from precise details to broader pattern recognition. The pattern is undeniably becoming more favorable for winter weather. The primary challenge, as always, is timing. Cold air may retreat offshore too quickly, or storm systems could track just far enough east to miss key population centers. So let me know what excites you more: a quieter cold and dry stretch, or the possibility of a more active and wintry pattern. At this lead time, changes are inevitable, but the larger signals are what matter most. We have a favorable jet stream, alignment along the east coast, accessible cold air, and storm systems developing along the jet. These are essential ingredients for coastal winter weather. Now it's a matter of watching how they come together or don't. The key question remains: do these systems stay offshore as near misses, or do they evolve into something far more impactful for the eastern United States? The contrast between warming conditions in the west and a cooling trend in the east becomes increasingly pronounced as this pattern transition unfolds. Major population centers across the Northeast and Mid-Atlantic should brace for a clear temperature shift after enjoying this week's unusually pleasant conditions. Cities like Boston, New York City, Philadelphia, and Washington, D.C. are all poised to transition from spring-like warmth back toward more seasonable January cold. The timing of when this colder air arrives is critical, as it will determine how effectively it can interact with available atmospheric moisture. Cities such as Chicago, Detroit, Cleveland, and Pittsburgh sit in zones where sharp temperature contrasts frequently generate intriguing and sometimes impactful weather outcomes. If you're in any of these areas, drop your city in the comments and share what kind of January weather you actually enjoy most. Farther north, the Northern Plains and Upper Midwest, including Minneapolis, Madison, Milwaukee, Hugh, and Green Bay, are regions that typically handle colder regimes with ease. These areas are accustomed to sustained winter patterns and may see multiple snow events as disturbances track through an already established cold air mass. Meanwhile, cities like Atlanta, Charlotte, Nashville, and Louisville lie squarely within transitional zones where temperature swings tend to be sharper and more volatile. Here, jet stream placement will be the deciding factor in whether these locations experience mainly rain and thunderstorms or flirt with wintry precipitation. As systems move through the southeast, the strong temperature gradient created by this pattern could help intensify developing storms. When we examine precipitation projections, some notable differences emerge between the major forecast models during this period. The European model highlights active snowfall potential in the Cascades and Rockies, but shows surprisingly limited activity for the Sierra Nevada. It also increases precipitation chances across the northern plains, upper Midwest, Great Lakes, and interior Northeast, while keeping Mid-Atlantic and southern New England activity relatively muted. The GFS model, however, tells a different story. It suggests more robust precipitation potential across the Mid-Atlantic and Northeast, while dialing back totals for the northern plains and upper Midwest compared to the European solution. This type of divergence between major models is completely normal at longer lead times and reinforces why forecasters prioritize large-scale pattern recognition over exact outcomes. Let me know in the comments what parts of forecasting you find most interesting when models disagree like this. At this range, broader signals such as temperature trends, jet stream alignment, storm timing are far more dependable than location-specific details. These pattern-level indicators help us understand what types of weather are possible, even if the exact specifics remain unresolved. For higher confidence in pinpoint forecasts, we generally need to be within about 10 days, and often closer to 7. That's why recognizing evolving patterns is so valuable out. allows us to anticipate potential rather than lock on to premature conclusions. This particular pattern contains several ingredients that could support meaningful winter weather, though the final outcomes are still uncertain. Thank you guys. See you next video.